In this tutorial video, I'm going to show you how you can calculate the number of grams of ammonia produced from 4 moles of hydrogen gas. I start off with a balanced chemical equation, which I actually provided for my students, so you don't have to worry about that in this particular problem. I'm going to start off with my GWR, the given, want, and ratio, same thing as relationships. The given in this problem is 4.00 moles of hydrogen gas. Remember that hydrogen is a Bringelhoff element. It's a diatomic, and you always have to put a subscript 2 whenever it's represented by itself. Now, if it's combined in a compound with another element, you don't put the subscript 2, only when it's by itself. Plus, if you forget the formula, just take a look at your balanced equation if it's provided, and wherever you see hydrogen, the same formula, use that in your given and your want. The want in this problem is how many grams of ammonia. Now, if you don't know what ammonia is and you're given a balanced equation, you can always use process of elimination to figure out which one is the formula for ammonia. This is nitrogen. This is hydrogen, which means this must be ammonia if you don't know what it's called. So this is ammonia, and now we can represent it by its proper formula. Make sure that anytime you write a given in your want, you're putting the units as well as the substance. It will make you so much better at these problems if you're very thorough. When it comes to writing ratios, you can look for some clues inside the given and the want. Now, in your given and your want, if you see 2 different substances, like in this problem, I see hydrogen versus NH3. When you see 2 different substances, 2 different formulas, take those pieces of the balanced equation and write a mole-to-mole ratio. For every 3 moles of hydrogen, there are 2 moles of ammonia. And here's how I would write that ratio. Now notice I actually wrote it flip-flop from the way I verbally said it. It doesn't matter which order you put the ratio in, as long as the ratio has the correct coefficients with the correct units and substance attached to it. See how the 2 is in front of the NH3? Just make sure everything stays together. Now, as I scan the given and the want for more clues, I see a unit of grams. Grams is a big clue to us because that tells us calculate a molar mass. We need a molar mass, and the molar mass we need for this problem is NH3. The reason why we're calculating NH3 is because I see a unit of grams next to the NH3. I don't see a unit of grams next to H2, so we don't need a molar mass for H2. And here is the molar mass for NH3. When we represent molar masses, we want to make sure to be very, very thorough. 1 mole of NH3 to 17.031 grams of NH3. The way this number was determined, it was calculated from the following numbers. On your periodic table, you find nitrogen because there's 1 nitrogen in the formula, and you add it to hydrogen times 3 because there are 3 hydrogens in the formula. So when you type in 14.007 plus 1.008 times 3 in your calculator, that's where 17.031 grams comes from. We're not finished with the problem. I'm going to take all of this information and put it on the next slide. And now we're going to start the problem. Starting with the given over 1, we're going to use the units in the given to help guide us through the rest of the problem. If I see moles of H2 in the given spot, I'm going to scan the ratios for moles of H2. There it is. And I'm going to take this 3 moles of H2 and put it diagonal from the given. We want our units and the substance to cancel out diagonally. Whatever the other side of the ratio is, that goes above the moles of H2. So 2 moles of NH3 for every 3 moles of H2. I can basically check off this first relationship because I've used it up, so don't accidentally use it again. I'm going to go ahead and move forward with the rest of the problem, making sure my moles of NH3 cancel out diagonally. So I'm going to take this piece of the ratio, 1 mole of NH3, and I'll put my 17.031 grams of NH3 in the numerator. My units cancel out diagonally nicely, leaving me with grams of NH3, which is great because that's what I wanted to end up with, grams of NH3. Now I can go ahead and type this into my calculator, and I'm going to type in 4.00 times 2 times 17.031 divided by 3. Notice I ignored the ones because I know they're not going to affect my calculation, and my answer, rounded to 3 significant figures, is 45.4 grams.